Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine building an AI agent that plans tasks, calls APIs, searches the web, and writes reports. Everything works until suddenly it fails. But here's the real problem. You don't know where it failed. Was it the reasoning step, a tool call, or a wrong assumption earlier in the workflow? This is exactly the challenge Microsoft Research addresses in the paper, AgentRx, Diagnosing AI Agent Failures from Execution Trajectories, authored by Shraddha Barke, Arnav Goyal, Alind Khare, Avaljot Singh, Suman Nath, and Chetan Bansal. And the idea behind it is surprisingly simple. Treat debugging AI agents like medical diagnosis. AI agents are no longer simple chatbots. They perform multi-step workflows, planning tasks, reasoning, calling tools, and interacting with environments. But when they fail, debugging becomes extremely hard. Why? Because agent execution is long horizon, probabilistic, tool-driven, and often spread across many reasoning steps. One wrong step early in the process can cascade into a complete failure later. Developers might see the final failure, but the real cause happened many steps earlier. And that's the debugging nightmare AgentRx tries to solve. AgentRx introduces a new concept. Find the critical failure step. Instead of just saying an agent failed, AgentRx analyzes the entire execution trajectory. That means every step the agent took: prompts, tool calls, intermediate outputs, reasoning traces. The framework then creates constraints that describe what should have happened. Next, it evaluates each step of the trajectory against those constraints. If something violates the constraint, AgentRx records it in a validation log with evidence. Finally, an LLM-based judge analyzes that log and identifies the exact step where the task became unrecoverable and the category of failure. So instead of the agent failed, you get something like step 7, incorrect API argument caused cascading failure. That's a massive debugging improvement. To evaluate this idea, the researchers built a benchmark of 1015 failed agent trajectories. These cover multiple real-world domains like structured API workflows, incident management systems, open-ended web and file tasks. Each trajectory was manually annotated with the critical failure step and a taxonomy of failure types. This dataset allows researchers to study how agents fail in complex systems and, more importantly, how debugging tools can identify the root cause automatically. Experiments show that AgentRx improves failure localization accuracy compared to existing approaches. AI agents are moving toward autonomous systems. Think about agents that manage cloud infrastructure, run incident response workflows, coordinate multiple tools. In these systems, debugging isn't optional, it's mission critical. AgentRx provides something developers desperately need: structured, systematic debugging for AI agents. Instead of guessing where things went wrong, you get traceable evidence and root cause analysis. It's like turning a black box AI system into something closer to a debuggable software program. But there's an important pitfall. Agent debugging requires high quality execution traces. If your agent doesn't log reasoning steps, tool calls, intermediate outputs, AgentRx or any debugging system won't have enough data. Practical tip: when building agents, always design with observability first. Log everything. Because debugging agent systems without traces is like debugging distributed systems without logs. AgentRx is an early step toward reliable AI agents. Because the future of AI isn't just smarter models, it's systems we can actually debug. And this research might be the blueprint for that future. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.